This is section 8.2. This is part 4. Now we are being asked to multiply two radicals and make sure our answer is simplified. Now the ones we did at the very beginning of this section, these individually could not simplify, and our answer in the end could not simplify. This one does. I can simplify the square root of 12, and I can simplify the square root of 48. Now what I said earlier about being able to reuse these, if you look at this prime factorization we did here for 24, if I cover up the 24, I have the prime factorization of 12. It's 2 times 2 times 3. I can also easily make the prime factorization of 48 because 24 times 2 is 48. So I can essentially add on to the top here. If I divide that by 2, I'm here. And I can reuse all of this. So one option would be to simplify each one and then multiply. Well, if I'm looking for the square root of 12, I don't have these top two. All I have is the 12, the 6, and 4. So I have a pair of 2's and then a 3 left over. So 12, the square root of 12 is 2 times the square root of 3. Times the square root of 48, I'll have a pair of 2's, I'll have another pair of 2's. 2 times 2 is 4. And I'll have the square root of 3 left over. Okay, so if I'm going to do it this way, then I multiply the numbers in front, 8, and then I multiply underneath the radical, so that's the square root of 9. But we know what the square root of 9 is, it's 3. So I have 8 times 3, which is 24. Okay, that works. Okay. It's usually not the easiest way. If one of these two had been a perfect square, then this would have been the easiest way to go. You simplify it completely and then just go see what you have. The other option is to multiply these two things together first. So I will do 12 times 48 under the square root. And if I do 12 times 48, what I have is the square root of 576. And then if you go to your calculator and enter 576, you find that the answer is 24 directly. If you wanted to do the prime factorization of 576, 576 is divisible by 2 because it's even, and you get 288. And divide by 2 again, because it's even, you get 144. Divide by 2 again, 72. And then 2 again is 36. And then 2 again is 18. And then you get a 9, which is 3, and a 3. So your pairs, everything pairs off. You have 2 times 2 times 2 times 3, which is 8 times 3, which is 24. It works either way. Okay, so let's go on to the next one. The square root of 7 over 16. Well, one of our properties says that we can take a square root of a fraction and split it up into the square root of the top over the square root of the bottom. So this is the same thing as the square root of 7 over the square root of 16. And I want to simplify these if I can. 7 is a prime number, so there aren't going to be any pairs. It is simply going to be the square root of 7. We're stuck with it. But the square root of 16 I can simplify. The square root of 16 is 4. So I have the square root of 7 over 4. This will be your answer. Now you have to make sure that this radical doesn't come down. You don't want to do this. This is something totally different. And you want to make it very clear that the radical is only on the top. It does not extend down into the bottom. Okay, so let's check on this next one. This one is similar to the one up here in that you can simplify each one individually and then multiply the fractions, or you can use the property backwards. So we're basically going to be using this. This says that if you're multiplying two things together, forget that they're fractions. You can multiply underneath the radical. So I'm going to go ahead and do that. So this will be 5 halves times 125 over 8. And I'm going to multiply these back together, and I'm doing that mainly because I didn't have any perfect squares here, and I'm really hoping one shows up. And if you do multiply, 5 times 125 is 625, and 2 times 8 is 16. Now use this fraction property and split it up into the root of the top over the root of the bottom. The square root of 625 over the square root of 16. The square root of 625 is 25. The square root of 16 is 4. Your answer is 25 over 4. All right, let's do one more here before I go to the next part. You have a lot of different options here. One of the things I like to do is we can think of this as the answer to a fraction multiplication problem. This would be the same thing. If you think of it just as multiplication, you multiply across the top. I would have 50 times the square root of 20. 50 times the square root of 20 is the same. 2 times the square root of 10. 2 times the square root of 10. Now, why did I do this? Because I can simplify it this way. All right, 50 over 2, that is 25 times. This is 25. Now what I'm going to do is I'm going to use this property in reverse. Right now I have a radical over a radical, and I'm going to combine them back into one fraction. Now why did I do that? Because that fraction simplifies very nicely for me. 20 over 10 is 2. So I end up with 25 times the square root of 2, which is simplified for us.